in our usual regression model, we assume they are kind of independent of each other, but one variable is, we can express actually one variable as a linear combination of others, right? We basically express age as a linear combination of firstborn, constant, school, and experience, right? Then what kind of problem we would have? What's your guess? What kind of problem do you think we will have? Can you guess? Can you really estimate this model in this case? Jay, how do you? Regression of beta. Let's rebound estimate of beta. So beta is basically we have to invert, right? X prime x inverse, right? We need this one. But if this x is like n I k matrix, k plus 1, k is number of independent variables and 1 is just constant. So in order to invert this matrix, right? So x prime x, we need it. So in order in a sense that, I mean, we can drop age in some sense. We can drop age and plug this equation into the here, right? But instead of age, we can put this process excluding process period. Then we can rewrite the equation. Then we can easily drop age, and this regression is just function of school experience and other control variables. So in some sense, in this case, one of those three are redundant variables. So we have to drop either age. We can drop schooling, and then to drop schooling, actually school is age minus experience, right? Or we can drop experience. I mean, economically speaking, even if we drop all of them, we will have exactly the same economic equation. And therefore, we shouldn't be. We cannot identify coefficient of this equation. Therefore, so our problem is that x prime x inverse does not exist because x prime x is not full. Consider an alternative model such that now we have the same model, school experience age and z alpha, and then suppose we have a different coefficient and alpha 0 is beta 0 plus 3, and then gamma 1 is beta 1 plus beta 8, and gamma 2 is beta 2 plus beta 3, and gamma 3 is 0. Right? Now in equation 11, in this equation, which looks different from 9, right? But actually they are same. But equation 11 can be rewritten if we rewrite equation 11, right? Then mathematically they are equivalent. In some sense, we cannot pin down coefficient for this equation. If we reshuffle this equation, we will get exactly the same one, but with different coefficient, right? Which does not make sense. Which is the specification equation 9. So basically, we can generalize equation 11 looks like this. So depending on the p, we change p. Here, we change p. This gamma 0, gamma 1, gamma 2, gamma 3 all change. And p can be any arbitrary number. Therefore, we cannot simply identify this parameter. Thus, the beta parameters in equation 9 are not identified. We cannot identify. How many, even if we have enormous amount of data, we cannot solve this problem. So it is not simply data problem, it is just mathematical problem. Unless we can find the data where equation 10 does not hold. Unless we find the data in which equation 10 does not hold, how many data we have? So in practice, okay, in practice, even if there is a not perfectly perfect collinearity, even if there is no relationship, even if relationship is not as perfect as this, if this kind of equation approximately holds, we have a big problem. Even if there is not perfect collinearity, or near perfect collinearity, the same type of problem occurs. In particular, as a set of values of which perfect collinearity, the covariance matrix of estimate of the associated variables explode. So, okay, how to solve this problem? So there are and how to solve the problem and what can you do? First, it is important to do diagnosis. Okay, it is important to find whether there is problem of multicollinearity or not. One easy solution is to use eigenvalues and eigenvector. Okay. So one idea is by analyzing this x prime x matrix and find eigenvalues, and if eigenvalues are either too big or too small, then we might have a problem. So one popular measure is like this. Max. To investigate the ratio between largest eigenvalue of the matrix and smallest eigenvalue, and if this number is large, then there might be a problem. But actually, so this is mathematical diagnosis. But maybe better diagnosis to think through the model, right? In this equation, clearly, if we think through this equation, is including schooling experience and age all together, it doesn't make sense. So this economic equation may be good. So in order to solve the problem, the best idea is to drop some values, drop redundant values. Another idea is principal component analysis. We already learned principal component analysis, right? So it is kind of principal component analysis is like variable reduction technique, right? So using principal component analysis, we put similar variable together and just extract common variable, right? And we can use that. In this case, if we do principal component analysis, then school experience age will cluster together. It's likely that they are clustered together. And third is find the better data. Better data, which means they find the data in which this kind of relationship does not exist. Any question? Next topic, more on regression. Now consider the following model. So y equals x0 beta 1 x1 plus beta 2 x1 square plus error term and loop 1 bracket. Third one is again non-linear equation. Fourth one is additive error. Okay. Discuss which of these are linear. Discuss the relation between second and third equation and distribution of the error. So until now we basically learned this type of linear relation. So, in our example, each of them are linear models. Here, what is among those four models, which of them are subset of this type of linear? Second one. 현정, how do you think?
I don't know the
Okay, my question is, okay, until now we learned model perspective and we have 4 equations. Which of them are kind of subset of that kind of model? Or which of them are not linear model? So let's look at the first one. So clearly, it is a relationship between y and x, and it is like a second order equation. So it looks like non-linear, right? If f and x squared, it looks like non-linear model. But actually, we can regard this one as like x2. Then it looks like similar to the linear model. So I mean, it is clearly not linear. It is non-linear model. Non-linear model, but we can express that as a linear model. So we can use our technique we learned until now to estimate this model, right? So even though my point is that even though we learned model until now we only learn linear model, but that linear model is surprisingly flexible. So we can even apply the linear model to non-linear case.
Is there exists multi-collinearity?
In this case, there is no multi-collinearity, right? You cannot express this as a linear function of this. This is non-linear function of this. So there is no multi-collinearity problem. So multi-collinearity is only linear relationship. And if I say relationship is not linear, it is fine. And about this one, it is also the relationship between y and x. So if we write down this one, actually, if we put exponential each side, okay, then this equation looks like this one, right? So I will tell you that this one is also looks like it is non-linear equation between y and x, but this one now looks like linear equation, right? You can regard it as another y, and you can regard this one as another x, x2. So to estimate non-linear model, okay, basically we can use that kind of specification to estimate non-linear model. So this kind of problem, let's write it down. So if we exponential each side, then we have y is exponential alpha, okay, 0, and x alpha 1, x2, alpha 2, and exponential of the u. So basically, when we have relationship like this, what we can do, in this case, we can take log each side, and again, we can use the same technique. And actually, this kind of function is very popular in economics. So suppose y is potential, and x is like capital, and x2 is like label. We call this kind of function as codominant function. And then we have a third equation, right? And then there is a third equation, and basically if you take exponential of this one, then you have this one. And if we compare this specification and this specification, then they look similar, right? They look similar, but actually there is a different assumption about error. In this case, since we have exponential, so we are assuming this error from entire error is always positive. Right? But in this case, this UD can be both positive and negative value. So this assumption implicitly means that in this case, y is always positive. But in this case, y can be both positive and negative value. This is similar. Now we have a relative error. So anyway, about third equation, when u has both positive and negative value. But if it is positive, u has both positive and negative value, basically we cannot put log each side. We cannot take log for negative value. So if if y can take both positive and negative number, we cannot transform our equation to this type of equation anymore. So it is truly in our perspective, we cannot use linear model. Fourth one is similar. We cannot transform this one into the linear equation. So again, to estimate this fourth equation, we have to use non-linear regression model. Anyway, my point is that even though we learned linear model now, that linear model is very flexible. So we can a lot of non-linear model. We can estimate a lot of non-linear model, linear specification like this. Now dummy value. Suppose we have an equation like this. Wage, double here double is wage. So low wage is function of education, age, sex, race, urban, whether living in city or not, and south, certain area or not, or disabled or not, and adult. Suppose we have an example like this, and discuss some binary variables such as sex. What does better mean? What happens if we change the meaning of sex, and what if we include the next purpose? Can you try to answer the first question? Kyung-chul? Let's try to answer the first question.
I think beta means the probability.
Beg your pardon?
Beta means probability.
What do you mean by probability?
So
dummy variable means, dummy variable means like 0 or 1. So when we have male, so we have only two values for this one, right? Either male or female, right? So when observation is made, we write 1. When we have data of female, we simply write 0. So this variable sex has only a value of 0 or 1, depending on whether gender is male or not. In this case, what does, so suppose we call male as 1 and female as 0, okay? Then what does this coefficient factor mean? Okay, so fantastic means the kind of, so female is 0, male is 1. So fantastic implicitly measure the wage premium in terms of the premium of male over female in the job market in terms of wage. And then another question is, okay, I think this was the board. What happens if we include both domains for both sexes? So in this case, we call male 1 and female 0, right? So we have one domain variable 0, 1. And suppose we have included another domain variable, in which case now female is 1 and male is 0. What would happen if we include that kind of both domain variables? So we have two domain variables, sex1 and sex2, okay? So we have observation 1, 2, 3, 4, 5, and data something like this. Right? So first data, so it is like people, first people. First data is like and second data is about Yuri, okay? Third data is like Sungi. Fourth data is like Sorry, something like this. Okay. So we have data. Then first domain variable is male 1, female 0. Right? So this is one domain variable. Now suppose we include another domain variable. So it is like 0. What would happen if we include both domain variables? 그래를 how do you think? 현정 how do you think?
maybe cancel out which.
Right. Right. So one will happen.
Beta 3 means
Actually, beta 3 can mean something. Okay. Actually, we need beta 3-1 and beta 3-2. So we have two variables, 1 and x2 like this. Okay. In this case, so if we include two dummy variables, like x1 and x2, then what would happen to this regression equation?
Yeah, two kinds of research is possible, depending on the weight beta-1 and beta-2.
Any other opinion? Okay, so then we have multicollinear problem actually, right? So if we add two the variable, if we add two what variable, we have one everywhere, right? We have one everywhere, so it will be constant term. So which is the first argument. Okay. So in that case we have multicollinear problem, so this regression equation will break down. So we cannot include dummies for both. So I have a homework for you. It's extension of the homework you already did. So in your homework, when we apply the sum of 23 factors, so R I is equal to 3 factors. So market premium So here's your homework. Now, suppose we are also interested in alpha of this step data. If we are interested in alpha, then we need a constant. We need a constant. Okay. Now, let us use another dummy variable. Right? Dummy variable. So sector dummy for sector. Okay. So in your homework now you have to extend the homework such that please download two stuff. Okay, two stuff in different sector. So like sector industry, some of them is IT or finance or IT and like consumer goods, something like that. So select two stuff. Actually, yes, two stuff for different. Actually, there is not one, okay? Download three stuff, okay? Three stuff with all different sector. All different sector. So, and include the dummy variable. And please investigate this effect of the dummy, the effect of the industry for stuff. So it is similar to this equation. So instead of education age things, so instead of education, let's even know this part. So instead of education age, we have simply stock factor, stock market factor, and instead of this gender variable, which is either 1 or 0, actually this gender variable too. So now we have race. So in race there are more than two races, right? White, Asian, right, black, and Latin American, something like that. So different races. So you can regard the sector of the stuff like race of the stuff, right? And investigate how the race of the stuff will affect the stuff. Okay. So in this case, discuss the multi-value variable like race. What do the coefficient mean on each variable? So in case of race, okay. Now, speak out only 3 races, white, Asian, and Afro-Americans. So, like Brad Pitt, okay? Brad is white, right? So it's value for Asian and Afro-American. And we have Angelina Jolie, okay? Brad Pitt. So Angelina Jolie is also is white, right? So 0, 1, 1. So maybe we have data for Will Smith. Will Smith is Afro-American, right? And then who's the Asian star?
Green.
Grocery.
Is it comparable to the any okay, right? 0, 1, 0, okay. And we will yeah, suppose we have data something like this. So her value so we have so this is the race domain, right? And similar to previous variable about gender, okay, we have the same problem. We cannot include all 3 domains, right? We should drop one of them. If we include white domain, Asian domain, African domain all together, then again we will have multi-collinearity problem because if we add them all, then we have one everywhere, and which is basically the first constant term. So in this case, we have to drop one of the dummy variable. So it doesn't matter which one we drop. Okay. And suppose we drop this white dummy. Okay. If we drop white dummy, then in the regression model we have 2 dummy variables, right? Asian dummy and Afro-American. Anyway, but not all black people are Afro-American. Anyway, we have Afro-American dummy and Asian dummy, right? Okay, in this case, okay, if we run regression, what would the coefficient mean? So it is coefficient for okay, so we have 2 dummies, 2 coefficients, which is beta 4-1 and beta 4-2. Yeah, suppose we run the regression and we have some value about this or this, so then what it would be? First, okay, what would be the value of beta 4-1 and beta 4-2 in United States? Would it be positive or negative? What?
I suppose it's negative.
Negative, okay. So it should be negative. And what would be the meaning of the coefficient then?
It means they have negative effects on their wage when they have disadvantage.
Okay, so that's right. So we can interpret this coefficient like it is likely to negative. So it is kind of we can interpret the coefficient as a wage, not premium anymore, wage discount of not being a white people in the United States. So in your homework, so instead of this, maybe yes. So basically, in your case, okay, we will have only 3 stocks. So Pitt stock, Jolie stock, Smith stock. Let's drop Brad Pitt. Okay. So in your homework, maybe you have to choose brain only to get 3, and maybe this one is IT, this is maybe banking, and third one is maybe consumer good. And what you can do is basically for 3 data, so it is like year. So we have a series of joins, right? Join in 2001 and only 2002, something like that. Because we have time series data. And of course, even though we have time series data, sector of course does not change over time. So you pick one of the sector as a base sector and drop the dummy for free and include dummy for only other. And you can drop the one regression. Okay. So that's the homework 1. And homework 2 is basically first homework is just include the dummy variable. And second homework is actually to discuss interaction of this sector and other coefficients. So in your second homework, what you can do is and so you have so again there is factor 1, factor 2 and factor 3, and suppose there is a dummy for IT and dummy for banking. Something like that. And so this is your actually I mean the constant here. So it's first homework, and your second homework is to investigate interaction activity. So you have to, in addition to that, you have to include first now, comma, and then maybe W1 and interaction of this IT and this first factor. Okay, first factor 1. And comma 2 is IT dummy multiplied by second dummy. Something like that. And also you have to interact this one into this one as well. Then how many independent variables you have? Okay, actually we have 3 factors and we have 1 constant. And we have 2 industry dummy. Actually we have 3 industry, but one of them is base. So we have only 2 industry dummy. And for each one we have interaction effects. So we have 6 interaction effects, right? So our independent variable will be 12. We will have 12 independent variables.
Professor, could you explain one more time why there's only 12 independent variables? Because there's 2 dummy factor and there's 4.
There is 3, right? Market factor and sign factor and value factor.
Oh.
We don't interact with the constant.
Oh.
It doesn't make sense. So, do you think you know what you have to do about homework? So then we discuss interaction sex and race. What do coefficient mean? If we do the interaction, so if we include sex and race, so in this case, okay. First is so if we regard male 1, female 0, 1, right? And if we want to construct interaction effect, first one is multiplied by Asian. Okay, so we draw this part in this case. So multiplied by Asian to be 0, 0, 0, 0, 0. Okay, they are all 0. Okay, this is not good. If we have all 0, then our configuration break down. Actually, we need another data. Okay, again, let's break it again. Hit 1, 0 and no, actually, it's wrong. So Brad Pitt is male, so 1. Angelina Jolie is female. Will Smith is 1. 1. So if we investigate Asian sex dummy, then we will have a good practice. And then we need another one. Okay, we need, and then Afro-American dummy. Afro-American dummy. Then Brad Pitt is male but white, so it is 0. Angelina Jolie is female, so sex is 0, so it is still 0. And Will Smith is male and Afro-American, so multiply 1, so it is 1. Okay, and Ray is 2. So it is just multiplication of this part and this effect. So in the interaction effect, so it is base. So we drop the dummy for white and dummy for female. We include only dummy for male and dummy for Asian and African American. We use the interaction effect and we have this kind of effect. And suppose this one is coefficient is 1, gamma 1. Coefficient for this information is gamma 2. And if we do the regression, and what would gamma 1 and gamma 2 will mean? What would they mean? Hyunjung, how do you think? What will this one and this one mean?
I think that gamma 1 is the level of sex multiplied by Asian effect to hold equation.
So, and what would be economic, not mathematical? What would be the value of the gamma 1 and gamma 2? Do you think it would be positive or negative? Suppose gamma is like, suppose we find gamma is like 0.03, what do you mean?
Male Asian's premium is.
Right, it is male Asian premium. So male is 1, female is 0, right? So it is actually, so we don't know whether it is really positive or negative, right? Because there is a male premium but Asian discount. So we can combine these together and we don't know whether it is positive or negative. But whatever the value we have, it kind of either premium or discount over just white people. Compared to ordinary white people, what would be by male premium? By being a male and Asian male, okay? Over just white people. Similarly, the sex Afro-American dummy is what would be the premium for black males, okay? Black male over just white people. Over just white female in some sense, because we always are female. By not being a female, which is male, okay? So what would be the premium of those people over white women in some sense? And then discuss interaction. Now, actually, we can even do the interaction of sex and race and education. Then it will be slightly more difficult to interpret, but yeah, it is possible to interpret. So it is kind of premium of education, or premium of education, but that premium of education can be moderated by whether whether a person is he or she, or whether he or she is American, and what kind of race is he or she. So in some sense, we can interpret the coefficient of this three-way interaction effect of moderating of education premium because of this gender and race. So in your homework, you have to do this three-way interaction. Three-way interaction. Just do the interaction of the second one. Any question? Let me write it down. So actually, this kind of interaction effect is like a non-linear interaction. So if we include this kind of interaction effect, basically this race and the wage become non-linear equation. But again, we express this kind of non-linear equation as a linear equation by regarding this interaction effect as vector. Now, joint test of several regression coefficients. Now, suppose we have a model looks like this. So, in our homework, maybe y is the stock return and x is the factors, factor of three factors: market factor, sizing factor, and value factor. And maybe z is industry domains. This is example. So, and consider the hypothesis. Suppose we want to test hypothesis such that all our coefficients or sectors are zero. Okay. Suppose we want to test the hypothesis. So this is null hypothesis and alternative hypothesis such that at least one of the coefficients or sector is maybe not zero. Okay, so it's basically joint test for the several coefficients together. T-value in the regression analysis, we have T-value. And just T-value is a single test for each value, whether each value is significant or not. But now it is joint test such that set of variable is 0 or not. Okay. It's testing for set of variables. Okay. Now, equation 1 can be reduced in the matrix form. So again, y is stock return, and x is factors, and b is industry domains. Okay, so beta is a factor loading, and gamma is a sector loading. And we can run regression like this. Okay, by assuming that we first assume that gamma is 0. So if null hypothesis is right, then we should plot this term, right? Then basically it is equivalent to run only equation. Right? So we can run only this relation, dropping the coefficient for factors in the case. And then maybe we can calculate residual sum of squares, right, by this operation. And of course we know this E term is projection of the y on only x, only null x, like this, right? I minus px. And also we can run equation 2 as unrestricted model. So first one restricted model because we restrict gamma are all 0. In second, we don't restrict, so it's unrestricted model. So simply we run this second equation. Right? If we run this equation, and again we can get this error and we get the residual sum of square. So unrestricted model. And again, this U is regression of the y on the null space of both x and z. Right? Regression of the y on the orthogonal space of both x and g. And then we can get the difference of between the two. Residual sum of squares of restricted model and residual sum of squares of unrestricted model. Okay? The difference is then E hat prime E hat minus U hat prime U hat. Do you think it should be positive or negative or unknown? How do you guess? What will be the sign of this part? 그러면 how did you guess? What should be the sign of that one? RSS R minus RSSU. J. What should be the sign of this one? Positive, negative, or unknown? Here. 이렇게 현정 소외 병철 이렇게. So actually it should be always positive, right? I mean it is so natural, right? So basically we fit y with two variables and we fit y with only one variable. So basically this one assumes that gammas are all 0 and we regress y without assuming that gamma is 0 in this case. Right? So basically if we calculate error then actually this u would be likely to be smaller than e in the sense. Right? By including more data, right? Including more data, at least we should be able to fit y better. Right? We fit y only with x in this case, and now we fit y both x and z. So error in this case should be smaller than this one, right? Right. So sum of the square, which is so graphically, we just have to actually it's possible. Well, suppose this is y, and suppose this is x and d. And if we assume that coefficient for z is 0, then basically we use y or only on x, right? And if we use both x and z, then basically we use y on the plane of x and d. And it is likely that in this graph, this looks weird, but this line should be shorter than this one, right? This one looks longer than this one, but actually, in reality, since this plane includes this plane, right? Since this entire space includes information about this one, so actually this line should be shorter than this one. So actually this one will be already positive. So if we write E hat prime E hat is basically y prime I minus p x y, as we learned before. As you remember, this one is idempotent matrix. And U hat prime U hat looks like this one. And we put this one together. And this equation looks like this. Right? And this one and this cancel out, and only we have this part. And what is the intuition for why this is positive? And this should always positive because of the intuition I just told you. Okay. And also, actually, it is not difficult to prove that this part is distributed with chi-square distribution with degree of freedom k. Okay. K is number of the variable for z. Okay. This is chi, and we know that this one RSSU, which looks like this part, and this one is distributed with chi-square distribution. Now with degree of freedom by t minus total number of variables, which is t minus n plus 1 plus k. Right? And then therefore, since this one and this one are orthogonal to each other, okay, why do you think this one and this one are orthogonal to each other? Why do you think which is independent means this difference of RSSR minus RSSU, the difference is one, and RSSU only different. What do you think they are independent of each other? Okay, let me skip that part for the timing. So anyway, they are independent. So because they and this one are independent, and both of them are this chi-square distribution. So by dividing this one with k and dividing this one with t minus 1 plus n plus 1 plus k, and if we do this operation, since it's the ratio of the chi-square distribution normalized with degree of freedom, so it should be distributed with F distribution with the degree of freedom k and t minus n plus 1k. Right? And of course, if we have infinite number of many data, many data, then this one will converge into chi-square distribution anyway. So basically, using this value, okay, we can do the test for the distribution. So if the really null hypothesis is right, so if this null hypothesis, if gamma is all 0, if null hypothesis is right, what would happen? If this hypothesis is really right. If this hypothesis is really right, what would happen to this F statistic? If null hypothesis is right, what will happen to the F? Why?
If the null hypothesis is right, and that will makes RSSR minus RSSU to 0. Right,
exactly. So if this null hypothesis is right, then actually imposing this one equal to 0 in this regression is very equal to just learning this regression, right? Because this one is anyway 0. So this RSSR minus RSSU would be 0, right? So if null hypothesis is right, this entire F distribution would be equal to 0. But if null hypothesis is wrong, then F is not likely to be 0 and it would deviate from 0, right? So F is already positive, so F will be larger and larger, right? So by investigating this F value, right, basically we can tell whether we can reject the hypothesis or not. So CD, so F is degree of freedom, so it is just 3D. PDE. What? Okay, beta distribution, F distribution, okay. So, this one. No, I think it's this one. PF. It's PF. Okay, F distribution, so DA, PF, QF, RF. Just okay. Degree of freedom, and DF gives density, and PF gives distribution function. Okay, so PF is what we need. To use PF, first you have to enter the value of Q, which is F value. So actually you can disregard this part. Okay, so instead of Q, you will plug this ratio, and then instead of DF1 and DF2, you will plug this K and T minus this thing. Okay, then you will have this P value for F. P value for F, and therefore if F is, you have F value, right? If F is smaller than 95, if F value is smaller than 95, then you cannot reject null hypothesis as 5% significant. And if F value is greater than 0.95, then it means you can reject null hypothesis with 5% significance. And if it is, the value is 99 and smaller than this one, which means that you cannot reject null hypothesis as 100 significant. And if the value is greater than this one, if the ratio is greater than this one, then which means that you reject hypothesis with the 1% confidence. Okay. And then, of course, actually it is chi-square test. This one will be slightly easy. So if you can do this one, you can do this one as well. It is up to you. And think about what would happen to this one as T with infinity. Okay, any question? What is that? So anyway, until now, the ratio of this one F test or chi-square test, they are called likelihood ratio test. Okay, so your homework is about conducting likelihood ratio test about joint hypothesis about coefficient of factor summits. Okay, and actually there are another type of hypothesis, another type of testing which is called Wald test. Okay, Wald test, and again, suppose we have a relationship like this, and suppose now we have assumption such that now the sum of weighted sum of beta is B, or weighted sum of beta is not B. Suppose we have something like assumption something like this. Okay. In this case, okay, suppose this is null hypothesis and the alternative hypothesis, and our question is how can you use this structure to test if two coefficients are equal to each other? Okay, how can you use it to test if two coefficients are proportional to each other? Something like this. How can we use it to test beta 3 versus beta 4? Something like this. So in case of this one, to testing, okay, testing. Suppose we want to test something like beta 2 equals beta 3. Then we can transform this one as beta 2 plus minus 1 beta 3 equals 0, right? Right. So in this case, C1 is 1, C2 in this case, so C1 is 1, C2 is minus 1, and B is 0. Right? And suppose we want to test a hypothesis such that B3 equal 4, B beta 6. In this case, it is natural that we can set C3 as 1 and C6 as minus 4 and B equals 0. Okay? So we can include all those hypotheses into special case of this restriction. Okay? So we want to derive the distribution of this one under H. So suppose under null hypothesis, if this is the right, expected value of this one should go to inside. And if null hypothesis is right, individual beta, okay, should be beta hat is unbiased estimate of beta. So we have this relationship, and variance of this one is we do this one, then we have covariance of this one and this one. Okay, so in matrix form, actually we can rewrite this one as C prime beta equal B or C prime beta equal not B. Okay, so therefore, expected value of expected C prime beta hat estimated beta, if null hypothesis is right, expected value of C prime B beta hat should be equal to B. Okay, this is the same statement as this one. And if we calculate deviations from the mean, T C prime beta hat, which is we can put C outside, and D beta, this part we know in our previous exercise, it is sigma square x prime x inverse, right? We learned this one. Therefore, D C prime beta hat should be equal to sigma square C prime x inverse C. Okay. Therefore, under null hypothesis, okay, given this relationship, right, the ratio of these two should have a T distribution. Okay. The ratio is T distribution, or if we multiply this, okay, then this one should have F distribution with 1 T minus n plus 1 degree of the freedom. Okay? Right? Because I think the correct approach is actually right, I think this is better. I think we went through some summary of the statistical results, but anyway, square of the T statistic conversion is F distribution, right? To remind your statistics knowledge, actually, we know that if we square root of the normal distribution, okay, then it becomes chi-square distribution, right? Chi-square, this means sum of the Z distribution, normal distribution. Likewise, standard normal distribution, F distribution is square. Square of the T distribution. So therefore, anyway, we have a T distribution. So therefore, basically this one is a square of this one. So it should follow F distribution. And in F distribution, of course, if we have a large number of data, since T distribution, if we have enough number of data, since T distribution converts to normal distribution, standard normal distribution, therefore F distribution should convert it to chi-square distribution. Right? So if we have a large number of data, we have this one. So, okay, your next homework, simply you have to construct this one. Okay, this one, and your next homework is I mean, although we have like 4 problems, because you use all your already conducted analysis. I don't think it will take much time to do all this homework because you reuse your previous result. Okay, conduct. What is about? Is 0. Okay, so in your world test, what you have to do is, since you have two sectoral domains, okay, two sectoral domains, so I want you to test this one. Actually, gamma 1 plus gamma 2 equals 0. Okay, you want to do world test about this. Any question until now? Right? It is very straightforward, right? Again, while the test is simply given this restriction, you calculate expected value and you calculate deviation from the mean. And you know, if you calculate the ratio of these two, actually you have to calculate the sigma square part. If this you know sigma square part, then of course this one is standard normal distribution. But since you have to estimate this and subtract out sigma square with s, therefore you have t distribution, and the square of. So basically, you can use this one to test your null hypothesis, or you can simply square this entire term, construct this one to do the F test about your restriction. Now, more general world test. So consider this model such that now C prime beta is B. So in our previous example, B is the constant, right? In our previous problem, B was constant. So now B is the vector. Now in our previous case, C is C was the common vector. So C prime was the vector. But now C is like a matrix. So it is like so in this case we have two restrictions like this. Then we can write this restriction, make it general. So it is like 3. Okay. And in this case we can write this one as okay. 0, 3, and then we have 1, 1, 0, 0, and 0, 0, 2, 1, right? So we can write down these two restrictions in this matrix form. Okay, and we want to test whether these two restrictions is true or not. No, whether we can reject these two restrictions or not. That's something we want to do the test. So in this case, the process is basically identical. So so we have this equation. So first one is we calculate expected value, and if our null hypothesis is right, then our estimate of beta, which is unbiased estimate, so expected value of C prime beta should be equal to B, right? And again, to calculate this deviation from the mean, then we can put C outside. So C prime and C, and deviation of V is again looks like this. Okay, and then next one is we wanna consider F statistic, which is equivalent to the previous case. So basically, we wanna calculate ratio between this and this, but we have to take into account when we construct F test. We have to take into account this part. Degree of the freedom of our restriction. So K in this case, number of restriction, right? Which is the number of column in the C. So in this case, we have two restrictions, right? Restriction 1 and restriction 2, right? So they are degree of freedom for the first part, and second degree of freedom is T minus n plus 1 part. Okay, n plus 1 is total number of variables, including total number of variables, including constants, right? So again, if we have this joint restriction like this, we can construct this test statistics and we can calculate F value. And once we have an F value, then we can see whether, once we have F value, then we can see whether this value is statistically, once we have value F value, then we can know under what confidence interval, under what percent of confidence we can reject hypothesis or not. Okay. Any question? Actually, this is all I prepared for today. Actually, I was too fast, I think. But we need variable regression. I think I can do this part from next week. Anyway, so we have some time today. Do you have any question about today's content and doing homework? Hyung, do you think you understand everything? If you don't, what is your question? Which part you can understand?
Professor?
Yes.
In the wall test,
Okay.
the C prime is just a form of matrix in the
Yes, it is matrix. Yeah.
Is that mean trace or just?
So it is any matrix to match your restriction. So it depends. This is C matrix. This part depends on what kind of restriction you want to give. So C is contingent on your restriction, your hypothesis. So actually, we learned likelihood ratio test, right? Actually, likelihood ratio test and word test are basically same. Okay, actually not same. They are different. Basically, they are different. But actually, the purpose of testing is actually equivalent. So in the likelihood ratio test, our hypothesis is something like all, for all I, right? Right. So it was likelihood ratio test. In terms of world statistics, we can do exactly this analysis by making C matrix like, okay, so suppose I is 1, 2, T, right? And what we can do is, we can write down, okay, T by T identity matrix, okay, and then, okay, gamma 1 and gamma T, okay, equal to 0. Okay, it is a vector of zeros. If we have another variable for like beta, then of course we should add beta over here, and in this case they should be all zero over here. In this sense, while the test, you can basically choose between likelihood ratio test and word test depending on your preference. Any other question? Jay, do you have any question?
I have a question on that.
Yes, try one by one. I think also this part, this part, if you are you wanna know more about this part, I think you can find the books. You can refer to what is our textbook? I never use textbook, right? Was there any textbook for this class? Oh, okay. Yes. Basically, we had a textbook, but I don't think this textbook has a good explanation about this likelihood ratio test and word test. Maybe we can do the web search. Likelihood ratio test. Yeah, Wikipedia. This article is missing citation, need footnote. Okay, likelihood for null hypothesis, likelihood alternative model. Okay. This is rigorous. I think this is rigorously written, but it is maybe too difficult for you to read at this point. Okay, word test has a good explanation in Wikipedia. I think it is simple. So if you have more questions about word test, please refer to Wikipedia here. And about likelihood ratio test, I think there are not very good sources at this point because it is likelihood ratio test, and I taught you the formula, but problem is that we didn't learn yet about what we mean by likelihood. We didn't learn likelihood function or likelihood value. Therefore, even though you read the book about this part, I don't think you can understand. Yeah, you're right. Actually, and we learned the likelihood ratio test, the word test. And there are alternative another method which is called the Lagrange multiplier method. Yeah. I think we will learn that one if we have time later on. Yes, Lagrange multiple square test. So they are likelihood ratio test and word test and Lagrange multiplier or competing techniques. Okay, if you don't have any questions, why do we start the class today? Okay. See you next week.